This video note continues on from the previous one, where we introduced the fundamental concepts of class and object. In this video note, we're going to see those concepts in action in a Java program, and we shall also introduce some additional fundamental terminology, words such as field, state, and method. In the previous note, we said that the word instance is often used interchangeably for the word object, and we summarized by saying that a class describes a general category of things, but individual objects are created from a class, and each created instance possesses its own copy of the characteristics of its class. We shall look at how this relates to object-oriented programming by using what in BlueJ is known as a project. This project is called Figures and is taken from the book Objects First with Java. A project corresponds to a folder containing Java source files and some other files that make up a program that can be run within the BlueJ IDE. You can open a project in one of two ways. The first way can be used if the BlueJ program is already running. Select Project, Open Project, navigate in the folder view to where your copy of the project is. The folder should have the BlueJ icon associated with it in this view. Select the Figures folder and then the Open menu. Let's close that and show you a second way. The second way is convenient if BlueJ is not currently running. Find the location of the relevant folder and open it. Find the file called package.bluej. The BlueJ icon should already be associated with it. Double-click on this file and BlueJ will start along with the project. The project should appear as you see here. If instead your project looks like this, there are stripes rather than solid rectangles in the diagram, select the Compile button on the left of the window. The stripes should disappear. If the stripes do not disappear for any reason, then you might be trying to use a version that is not in your personal file space, perhaps the one on the CD. Rather, you should make your own copy of the project files and work with that. The main area within the BlueJ window is occupied by what is known as the class diagram for the project. Each rectangle represents a class in the project, and the arrows between classes represent links or associations between the classes. There are 5 separate classes: Canvas, Circle, Square, Triangle, and Person. Notice that the names all start with a capital letter, which is a common convention in object-oriented programming. Thinking back to our discussion of how the word bicycle describes a category or class of things, it should be easy to see that the word triangle works in exactly the same way. We know that a triangle is a 3-sided enclosed shape, but that doesn't tell us how big a particular triangle is, what colour it might be, or whether the sides are all the same length or different. While those aspects might be captured in our notion of what it means to be a triangle, specific cases will belong to individual instances of the triangle class. One might be small and green, while another is large and red, for example. So let's create an instance of the triangle class, our first object. Right-click over the triangle class in the class diagram and select New Triangle. A dialog box offers us the chance to give a name to this object. The one offered is fine for our purposes, so we just select OK. Something has now been added to the area at the bottom of the BlueJ window. This area is called the Object Bench. What appears there does not actually look like a triangle. In fact, it looks more like a circle or a square with rounded corners. So what is it? This is BlueJ's representation of an object. All objects will look the same on the Object Bench. Their shape is not related at all to the class they were created from, so don't be confused by that. A bicycle object would look exactly the same. Objects on the Object Bench display the name they were given when they were created, Triangle 1 in this case, because we accepted the default name. They also display the name of the class from which they were created. Let's create an instance of the square class and confirm that these things are indeed the case. This time we'll give the object a name of our choosing. Box. If these are individual instances of their respective classes, then we would expect them to have individual characteristics. For instance, we know that all four sides of a square are the same length, but how big is this particular square? We can find that out by opening an inspector for an object. An inspector is a tool provided by ofwj for looking at the details of an object. Let's open an inspector for the square to see if we can find out how big it is. Right-click over the square object. Note it's the object, not the class, that we click over this time, and select Inspect, which is in red letters at the bottom of the pop-up menu. What we see now is a larger version of the red object shape. Its contents reveal details of this particular square object. We won't worry about all the information shown here at this stage, but it is clear that there are values for the square's size, i.e. the length of its sides, its position, its colour, and its visibility. The fact that it has a size, a position, and a colour suggests that it should be possible to visualize the square in some way, but notice that its visibility is shown as false, which suggests that we are not meant to see it yet. What an inspector displays are called the fields of an object. Which fields an object has are determined by the class of that object. The set of values stored in the fields of an object are together called the state of that object. It is common for the state of an object to change throughout its life. In other words, the values in some or all of the fields will be changed from time to time. We shall see some examples of that shortly. If an inspector is open for an object, then changes to that object's state will be reflected in the inspector. It would be quite nice if we could actually see a visualization of the square we have created. We could try changing the visibility value via the inspector, but the inspector doesn't allow that. This is because one of the principles of object orientation is that it is the objects themselves that are responsible for looking after and making changes to their state. If we want to change the state of an object, we have to ask the object to make that change. So how do we ask the square to change its state so that it is visible? Right-clicking over the square object again brings the menu we saw before, but this time we are interested in the main block of options. This contains a list of what are called methods. Scanning the list, we can see one called Make Visible, which sounds hopeful for visualizing the square, so we select it. What now appears is a new window containing a red square. Notice too that the visibility part of the square's state has changed from being false to true. This illustrates that some methods are state-changing methods. What happens if we call the Make Invisible method on the square? The square disappears from the window, but the window remains on the screen. If we call Make Visible again, then the square reappears as before. In summary, we have seen quite a lot of things in this video note. How to open a project, that the main area within ofwj is the class diagram, that we can create an instance of one of the classes in the class diagram by right-clicking over its rectangle, that instances are placed by ofwj on the object bench, that we can see the fields of an object by opening an inspector for it, that the inspector shows the current state of the object, that we can call methods on an object, and that some methods are state-changing methods.